Awesome, awesome. So we started looking at our collection data types, right? And in our last class, we took a deep dive into list. We looked at list. We looked at the properties of list. We touched on the fact that the list can be changed, they are mutable, they can be indexed, order is preserved, and we went ahead to see all the different specific functions that apply to list. Like we looked at the append, we looked at the uh, append, we looked at the length, all those specific functions that would apply to a list. And then uh, we went ahead to talk about tuples. It's another collection data type. And the thing is, with tuples, uh, they behave like lists, the same, but the one good thing about them is that they are not mutable. You cannot change them once they have been created. We try to illustrate that, and then we also said for you to create a tuple, you needed square bracket. Meanwhile, to create a list, for you to create a tuple, you need round brackets, and to create a list, you need square brackets. Sorry for that. And so those are some of the things we've looked at in our previous classes up to date. So before we proceed today, is there any question, any doubt, any addition, any subtraction as to what we have done? Are we on the same page or somebody still lagging behind? Okay, I'll take the silence to mean that we are all on the same page. Okay, so today we would continue to look at collection data types. And this time around, we'll be looking at another data type called a set. You know, if you attended primary school like I did, our teacher used to draw something like this, right? They call it set A, they call it set B, right? I remember we used to do this thing. Here they'll put 1, 2, 3, 4. Here they'll put 2, 4, 6, 8. And then they'll begin to ask us things like, they can even put this inside another thing that they used to call a Venn diagram. They'll draw it like this, right? We used to do these things in primary school. This is set B. And you see, our teacher will begin to tell us to do things like A, intersection. Things that we used to do. And so when they talk of intersection, this one, what we will do is that we'll take A, they'll draw it like this. And so our teacher used to say this part is the part that is intersection. When they say union, they used to say we'll take this one and combine with this one, you know, all those things. Some cool stuff that we used to do back there in primary school. That was still elementary school. And today we will be looking at this concept. We study the theory, we'll look at how some of these concepts are being applied. And we're going to see how Python itself treats these kind of data types called sets. So let's see. So a set is an unordered collection of multiple elements. Now I like the way I said this one because I remember when we were talking about list, I remember I told you that lists were ordered. I remember I said lists were ordered, like as in there was order. Like order is preserved for list. So So but then today I'm telling you that sets are unordered. What does that mean? Okay. So but before I show you how sets are, let's show you how to create a set. Okay. How do you create a set? If I want to create a set, let's see, I can call my set S is equals to, all I need to do is I write whatever I'm writing in square brackets, right? And if I write it in square bracket, I can create a set of numbers and I can say 1, comma 2, 3, 4, 5, 6. So this is a set. This is a set of integers, for example, because it's a collection data type. So it's going to be made up of some of the fundamental data types. So this is a set of integers. And so what is the take-home message we want to communicate here? The thing we want to communicate here is that when you want to create a set, you use this curly bracket. These are called curly brackets. These kind of funny brackets. We use curly brackets to indicate sets, to show sets. And so if I print S and I print the type of S and I print the type of S, we should expect to hear it says this is S and S is of class set. So now because I have seen this, I am now very sure that this is a set that I have created. So let me print S again. And now I know the other day I was telling you that sets are unordered. So when I say they are unordered, it means there is no index assigned to any of the elements. So if I want to do S, for example, S of position 0, let's see what we get. You see, I have an error message. We say set object is not subscriptable, right? This is to tell you that you cannot, there's no order preserved in sets because they will not have any index assigned to them, right? So that's it. We are already looking at some of the properties of sets. Okay, let's continue. We can create a set. It's a homogeneous set. It can be heterogeneous. So you can create a homogeneous set, right? So I can create a set of numbers. I can say S is equals to. So again, I write my curly bracket. I can have 1, comma, A, right? Comma, 5. So this is kind of a set. Let's see if we return S. If we print S, and then we want to print the type of S, and then want to print the type of S, right? Type of S. Let's see if we are going to get a set. Yes, it has printed a set for me. And now take note of something. You see, A in my set was before it turned down true. I don't know whether it's because I cannot take true as a value, but it's fine. But if you look at the way the set was, A came before 3.5, but when I printed it, you look, 3.5 came before A. And I told you order is not preserved. It's because there was no index assigned to this, so there is no order preserved here. So you wouldn't have the values the same way you would have expected them to, to appear. So you cannot index them because there's no index assigned to them. So now we've created a heterogeneous set. This was a homogeneous set, right? This was a homogeneous set because homogeneity is the fact that every element in that set is the same, and heterogeneity is the fact that they were different. So we've created a homogeneous set, we've created a heterogeneous set. Let us look at something again. Create a set having a single element. Yes, we can create a set having a single element, of course. I can say S1. I don't want to kill my S. S1 should be equals to, I can create a set having just one element, right? I say 1, right? And if I print S and I print S1, sorry, print the type of S1, which is S1.S. If I run this, I get my set and I get the confirmation that what I have created is of class set. Okay. Now, something comes here. Now, how do I create an empty set? You remember yesterday when we were talking about creating an empty set and empty tuple, we just say if I want to create an empty tuple, for example, if I say T is equals to, I just have to put it like this and this becomes an empty tuple. If I want an empty list, I say L is equals to this and this is my empty list. But then you'll be tempted to think that that is the same thing we have to do with a set. No, it's slightly different. We can't do the same thing with a set. So for you to create an empty set, for example, S2 is the set that you want to create and it's empty. You have to explicitly use the word set, right? Which is a function, and then you pass your whatever you're passing inside. And so when you return S2, it's going to say it is said. So let's see whether we can bring the type of S2 just for confirmation sake. It's of class set. So so for you to create an empty set, you have to use the constructor. So if you notice, we have talked about, before I forget, I know I might have missed that, we have talked about a couple of things. And if you are paying attention very well, you'll notice that we started by talking about strings, right? I want you to notice something. Before strings, we talked about float, we talked about int, we already talked about this one. So I said there was not much to discuss there. We've talked about strings, we've talked about list, right? We've talked about tuples, right? And then we're now talking about set. If you notice there's something that stand out. If I want, I can create any of these from the constructor, right? I can create an integer using the constructor of int. That's int, and then I pass whatever variable inside here, and it's going to create the variable, be making it an integer. If I want a string, I use str. If I want a list, right, I'll use the word list. If I want a tuple, I'll use the word tuple, right? And if I want a set, I'll use the word set. So this, we're going to look at this once we are done, and the concept is called typecasting. We're going to look at it, but just to highlight you the fact that you use these constructors. You saw this when we were creating strings. I show you how to create a string from the constructor using the str function. So these are specific functions that you use them to create the data types that the names point to. Okay. Okay, that was it for the first part. Any questions? Any doubts? Any input? Any outputs? Any
Good evening, Prof.
contradictions? Good evening, sir.
Yeah, it's Tony.
Oh, Tony, how are you today?
I'm fine, sir.
Good,
So,
sir.
regarding, I just, I think I have an input to make. Regarding
Mhm.
why that set that you define that has the homogeneous set that has the true and one and all the rest of them, but returned,
Yeah.
yeah, when returning the set, it did not return the true. So I think
Mhm.
why it didn't return the true is that set returns unique elements.
Mhm.
Let's say if you have 1, 1, 2, 2, 3, 4, 5. So it will return just a single one, a single two. I think it's also among the properties of set that you define. So coming to
Mhm.
that, I think I don't know. I think in Python or in programming, one means true represents one, something like that. False represents zero,
Oh, yeah.
something like,
Zero.
yeah. So I
Yes.
think it returned one instead of returning true, as a unique distance. So I think that's why it returned one without
Oh,
returning
that's
the.
great. So let's test that hypothesis and confirm and convert it to a fact or a theory, right? Uh, so instead of having this, so we are going to explicitly take out one, right? And then we see if we get right. It will also be nice to test this and confirm. Yes, you are correct. You're very correct. So it considered one here as a unique value, and since true is also one, it's going to return one, and it's not gonna. We are going to look at that in the properties of sets. Thank you very much, Mr. Tony. That was a great input
You're
there.
welcome. You're welcome.
Any other inputs, any other subtraction, any other spice to come and add it and make it. I'm seeing some chats. Okay. Okay. If there is no other input or there's no other subtraction, let's look at some of the properties of set, right? Let's look at some of the properties of set. The very first property of set that we're going to be looking at is the fact that it's unique. And that is what Mr. Tony was trying to explain down there, right? And so if I happen to have created a set, let me pick this set that I created over here. I have to create this set. And then if I created a set like this, assuming I have to add, say, if I say 2 and then I add 3 again, that means I have 2 double and 3 double. And if I return S, right? If I return S, you see it's not going to print 2 and 3 multiple times. So in another set, in another sense, what we are seeing is that sets what they do not accept duplicates, right? It doesn't accept duplicates, so you cannot have a duplicated value within a set. That's one way of, and this comes in really handy at times, right? Because even me, I use this a whole lot, At times I have my data and they are having a lot of duplicates, and possibly I have that data, particular data that comes in as a list, and it has a lot of duplicates. And for some reason, I just want to understand the unique nature of it. Sometimes if I don't want to go into pandas and start using that, I can just convert that thing. For some reason, I can just convert it and whip it into um into a set, and it's going to return only the unique values and nothing duplicate. So it's a very handy feature of sets that you can always utilize once we are once you are trying to create your models and write your code. And trust me, there are certain situations like from my own experience, right? There are certain situations whereby you find yourself stuck on trying to solve a problem. I've done that a couple of times. I find myself stuck on trying to solve a problem. There are a lot of packages out there too that we can use pre-written code from them to solve a problem. But at times it just gets so challenging to understand those packages or the functions that are already there, the different parameters. And so at the end of the day, there are times that you just have to go back to your core Python and use your core concept and create your own your own function from scratch, because that way you understand the function that you've created and you can actually go and change it the way you want. I mean, I've done that a couple of times. Yeah, you yourself, you get to find that frustration too, right? I remember there was this data set we were working on. There was something we were just trying to do. It wasn't going. We were trying to use pandas and the different functions in pandas to get the expected results. It wasn't going. We had to go down and write our own functions using core Python, because all of those packages and functions have been written using core Python. And so we had to go back and write our own functions and packages using core Python. And if you have to find yourself in a situation like that, and you need to output a certain unique output with no duplicates and things like that, you might find yourself having to utilize sets where you are making good use of this property of sets, which doesn't accept duplicate. So When we teach these things, please take them really serious. Okay, let's look at, we just proved that sets do not accept duplicate values, and we just illustrated that here. Let's look at another property of set. Sets do not allow mutable data types. Okay. I find this so funny. I remember the day we read this. They say well, I'm gonna tell you the story down, but let me first of all prove that it doesn't accept mutable data type. Let me pick somebody and the person is going to tell me, Madam Constance, can you give me an example of a mutable data type? Wait, let's start with, what does the word mutable mean?
Mutable.
Yes.
How do I put it? Mm. Silent.
Okay. That is your own definition. There's a female doctor here. Sorry if I've forgotten your name. At times it's difficult to recall. A female medical doctor. Who is that? If you are more than two, you can all come up, but I know of one. It's just the names at times run off my mind. Where is she? Is she there? Okay, let me look. Today I'm after the
If
ladies.
I may come back in,
You have a
something that
different.
varies.
Okay, okay. Yeah, something that varies. And so, can you
It
give me an
can
example of a
be
data? It's
it
reliable to
can be
change. That's what it
changed
means. Yeah.
over. It can be changed.
Mhm.
It's dynamic.
So, can you give me an example of a data type that can be changed or updated that is reliable to change? Mhm. Do you know of any data type that you can update? This one is for ladies. The next question will be for the guys. So let me look for another lady who will come and help you. Madam Bisuri, you are another lady on the line. Come and help Madam Constant. Both of you can be on mute so that you share ideas. Let's get that answer. Madam Bisuri Pearl, are you there?
Yes, I'm sorry. I'm just from entering class. I've been having internet problems. So I'm feeling
Oh,
kind of lost, but at least I'm sure we're doing the data type sets today. I just entered 2 minutes ago.
oh no, that's fine. That's fine. Okay, so let me let you settle, okay? But I'm gonna come back for you. You are not free. Okay, let me go for Madam Prudence. Madam Prudence. Is Madam Prudence there? Yeah, I can see her. Please, can you give me an example of a data type that is mutable? If Madam Prudence is not there, Madam Van Dolin, can you help her? Give me a data type that is mutable, an example of a data type that is mutable, that is reliable to change, can be updated. We've talked about this a couple of times. Oh, did I get an answer from someone?
List.
Is Alicia a male or a female?
Male?
Okay, so now the men are coming. Are you coming to save the ladies?
Yes, I'm coming to save them.
Okay, awesome. You're a gentleman. So can you give us an example of a data type that is mutable, sir?
Okay, so as was earlier mentioned that the data structures that can be modified after they are created. So an example of a mutable data structure is a list.
Okay, a list. Great. Thank you for that answer. So now let's look at what we said. We said sets do not allow mutable data types. That's what I'm saying. So he is saying an example of a data type that cannot be mutable is a list. So let's see. whether if I create a list in this set and then I run it. So I'm going to create another element. And this time around, my element is going to be a list. So my list can just be 2, 4, 6, or 6 or something. Yeah, that's my list, right? And so I'm going to print it to our set. And because it's a mutable data type, the set said, no, we don't want this kind of OGA in our midst. Okay. The next property of set. And the next property of set says set itself is mutable. Yeah, this is where the fun came, right? You do not allow mutable data types, but you yourself, you're mutable. So you say you don't eat dog meat, but you tear it with your teeth and share to children, right? That's what my professor said. So how can you say you don't eat dog meat, then you use your teeth to tear the meat and share to children? So how can set say we do not allow mutable data types and they themselves are mutable? That means a set cannot take a set. That's what it means. Is that correct, Elisha?
Yes.
If sets do not allow mutable data types and they themselves are mutable, that means sets cannot even take sets.
Yeah.
Is that correct?
Very correct.
Yeah, okay. So let's give it a try and see. Let's see. If they say they are mutable, that means we can add something to this, right? We can add something to this. So let's see. Is there a function to add? So let me see. I think if there's a function to add, add, maybe, I don't know. I hope there's add that works for. Is it there? I don't know. Let me just add what 7 and see if there's an S. Yeah. So you see, we just added 7. That means it's mutable, right? Because we added a value, right? So that means this guy is mutable. But then let's see whether a set will take a set, just to prove that a set is mutable, right? We just showed one way. So like we were discussing, we said if sets do not accept mutable values, we proved that here. And then we are saying again that sets themselves are mutable. And then that means sets cannot take sets. So let's see whether we can create a set and we have a set within a set. So I'm just gonna copy this back. And so instead of wrapping this with square brackets, please, I will just have to use curly brackets here. That means I'm having a set within a set. And so now, having discussed this and said sets do not accept mutable data types. So let's see. If I run this, you see, it says unhashable type set. So sets themselves are mutable, and that is why a set cannot accept a set. Is that clear? Are we clear on that?
Yes, it is, sir.
Awesome. So now let's
Yes.
look at something again. Okay, and we just showed that, right? Nesting of set is not possible. So you cannot nesting, it's like a set within a set. I just showed that, right? And I explained why, right? I explained why. Because a set is mutable and sets do not accept mutable data types. So you cannot nest a set. You cannot have a set within a set. Indexing is not possible. Yes, it is not possible because order is not preserved. Order is not preserved. So how can indexing be possible when the order is not even preserved, right? So you understand? So it's not possible. So we cannot say S of position 0 like we always do. This is not gonna work. Because like we said, no indices have been assigned to these elements as long as it's a set. Okay, great. So we already know that. because we are already big people. Let's look at some other thing again. Now, okay, before we go further, is there anything you didn't understand as far as the properties of sets are concerned? Because you need to understand these properties to be able to know when to use which data type, right? For example, if you really do not know these properties, you cannot really know when to use a particular data type. So, is everything clear? We just finished. Where is best man in class? Best man, are you in class?
Yes, I am, but a bit engaged today. I'll be listening.
Please tell whatever is disengaging you to re-engage you back, okay? Best man,
Yes,
whatever is
yes, Prof.
disengaging you, tell it to re-engage you back. Okay, now we're done. We're done with the properties of sets, okay? So the next thing we're going to be looking at are all these common functions. I don't know if there is a function here that you do not understand before. If you know of any function here that you don't understand, please tell me. Otherwise, I'm going to skip that part.
Sum in set.
Jamin. Okay, yes, Mr. Anthony, go ahead.
Yeah, I say sum in set.
Or sum in set. So let's see whether that works. So can I have a set? What is my S? Oh, great. So if I say sum of S, so let's see what we get, 28. But if they are heterogeneous, you don't expect a value, right?
Hmm.
Is that correct? Like you cannot do that for this set, right? You know you can't do that for this set here.
Yeah,
You
sure.
do that for this one.
Yes.
But if you have float, homogeneous float values, or and so it is right for us to say, when we have something like this, it is right for us to maybe add here that applicable only to homogeneous 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 float and int values, right? So we can make that judgment, so we do not make a mistake. Jamin, do you have any common function that you do not understand? Jamin, are you there?
Sorry, my background is a little bit noisy, but so far so good. I think I don't have any major worries as far as the results are concerned. Thank you.
Okay, thank you. So let me look for some other person and
This
get
can we do the last function, the delete? I'm sure it's a delete del function.
okay, that will be done. But let me ask somebody a question, okay? I just pick people at random just so I'm sure that this thing is going on. Milton? I don't know, the name sounds new. Milton. Yegong Milton, are you there, sir?
Good evening.
Yes, Milton, how are you doing?
I'm fine, and you?
And I'm doing great. Looking at these common functions that we have here, do you think
Yes.
you understand all of them?
Yes.
Oh, great. And so if I use this one, what is it going to do? So I want to use...
It's going to arrange the elements. If you don't pass any value, it's going to arrange them in ascending order depending on their ASCII value.
Okay, so I'm going to do that with sort. I'm going to do sorted, and then I'm going to pass S. So what is the expectation? What am I going to get?
You get 1, 2,
This
3,
is my
4, 5.
S.
1, 2, 3, 4,
Okay,
5.
I'll get 1, 2, 3, 4, 5. And then, but I want to do, I want to change something here. So what am I going to get?
You get 7, 6, 5, 4, 3, 2, 1.
Awesome. Thank you very much, Milton. That was just a confirmation of the fact that we did a great job.
Okay, sir.
Okay. So, Who asked me to use the delete function? Okay, Alicia, you have a question? Yeah,
Yes,
Alicia, your hand is up. Please,
I
can
have
we
a
take can we
question.
have your question? Yes.
So when we pass this sorted function, does it actually change? Let's say for example on a list, since these ones are on ordered. Let's go to ordered list. If you pass the sorted function to an ordered to a list, does it actually change the elements in indices, or it just displays this sorted version? That's
If you reassign it to a new variable, the element indices will change.
okay.
You understand? If I reassign this output to a new variable, not S, it's now going to take this output. For example, if I say U, for example, is equals to this, and if I return U, right, you're going to see that U is going to be this. And now the unfortunate thing is that the output is a list. And so if I do U position 0, right, you can get 7. But assuming S was a list, and I do S position 0, I'm not going to get 7, I'm going to get a 1. Does it answer your question?
Oh yes.
Okay, awesome. Somebody wanted us to delete, so I'm looking for a function that I can let me create a list that I can delete. So I want a list that you something that once I delete it, you know that I deleted it. Where are all of these things that I've created? I just okay. I'm gonna pick this. This is me returning S5. Now there's something that's gonna happen now. If I use the delete function, right? If I use the delete function and I pass S5 to the delete function, and then I ask what, and then after running this, if I ask what is S5, it tells me S5 is not defined. So delete means clear it from my memory. If you understand Pidgin, it says move them. Move them. That's what delete does. Who was that? Mm. Madam Madeleine, that was you, right? Whoever asked the question on delete, is it clear now? Okay, the person has entered Susongo. So since set is mutable, we can add, we can delete a variable, we can update, right? So how do we do all of that, right? So let's see. We can print the dir of a set, and we see some good cool functions there. Specific functions, of course. So when we do that, we see the add, I've choose add, it will add a value, clear will clear everything, copy will copy, difference will, oh, this is, now, this is where things are really exciting, right? This is where sets shine. Because aside the fact that sets will not hold duplicate values, the place where they shine is the mathematical power that they have to do certain mathematical operations. You understand? So let's look at it. Let's look at it, right? Okay, so before we do this, I'm going to create two sets, right? My first set is going to be S1. And I'm going to create my S1. I'm going to say my S1 is just going to be 1, 2, 3, 4, 5, 6, right? That is my S1. And I'm going to create another set called S2. S2, and my S2 is just going to be 2, 4, 6, 8, right? Maybe 10, okay? 2, 4, 6, 8, 10. This gives me my S2. So I've created two sets, S1 and S2. So now let's begin to do some mathematical operations and see the sweetness of set. Let's start with the difference function. So let's see what difference will do. So I'm going to do uh um let me say S1 dot difference, I think, and then I pass S2. You see? Now let's look at what has happened, right? It has taken S1. So it gives you the elements in S1 that are not found in S2. Did you see that? If I did trust you that if I change this order, it will give me a different value. Hope you know that. If I change S2 dot S1, so I'm looking for the difference. So it's going to give me 810. So these should be the values that are in S2 but are not found in S1, right? That is the thing. If I remember my thing well, it's something called A intersection B prime. If I'm not mistaken, those people who remember the olden days mathematics. That is the A intersection B prime. These should be the elements that are common, between both sets, but are not, I don't know. That are common in both sets, but are not found in A intersection B, something like that. Yeah, I don't know if that's correct, but it gives an idea of what I'm trying to talk about. Yeah. That's me trying to relate my olden days mathematics to this one. Okay, that was it for difference. Let's look at another cool feature. So you can do difference update, right? And it's just gonna add, so it's just gonna add the difference to the new set, right? So if so how do I do this? I can do this one. I can do this one, right? So I can do S1 dot S2 difference update, right? Update. So if I return this and let me ask S2, am I asking for S2 or S1? No, let me ask for S1. S1. Oh, this one was supposed to update it. What is it supposed to do again? Oh wait, let me see. Let me assign this to S3 and then I run it and see equals to. So that I get the updates, right? Okay, so I get S3. All this. Let me do this. Let me do this. Let me do this. I just want to try this, okay? Yeah. See if this guy will give me good information about this. When I do this when I run this as a string. No Python documentation found difference update. Use help to get the interactive. Why is this thing not giving me a result? Use help str4. Okay, let me do something. Help set, right? Difference update. It says remove all elements of another set from this set. Oh, the documentation is so shitty. Returns the difference of two or more sets as a new set, okay? That is all elements that are in this set but not the other, okay? So when you come down to this one now, you just write a very vague statement. Remove all elements of another set from this set. Oh, okay. No, I understand. Oh, thank you. I understand. So what he's saying is that, so now do you notice something? Nobody even noticed, even me that even ran it. I did not even notice that S1 changed. Did you not notice that S1 changed? See what we had as S1. Now, when I came down and asked what is S1, look at what I got. So what happened to this long thing here? You notice that all the elements that are in this long thing that were also in this one have been removed, like 2, 4, and 6. So you see, that's what the difference update will do. I was just trying to place my head around it. Okay, I hope it's clear, right?
I have a question.
Yes. Yes, please.
It means difference update and difference are the same, right?
Oh, no, 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 no. They're not the same. Mm-mm. Don't mistake that. Let me explain why. Oh, in very simple terms. In very, 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 very simple terms. Please don't overthink it, okay? Very, very simple terms. Difference, if I say S1 dot difference S2, I'm looking for the elements in S1 that are not found in S2. In English, just take the English like that so that you don't confuse yourself. If I say S1 dot S2 dot difference S2, this means I'm looking for the elements in S1 that are not in S2. That are not in S2. So what does it mean? 1 is not in S2, but 2 is in S2, so I don't take 2. 3, 5, and 6. That is what difference does. But difference update changes S1 completely because it will look for the elements that are in S1 and not in S2 and then delete the elements that are common in both sets from S1. They are not the same. That is why when I ran difference update and then I asked what was S1, I got S1 as this and not this. But let's see, if I run this again, and then I run this difference, let me run this difference now. If I run this difference, I want to add a cell here. If I ask, after running a difference, if I ask what is S1, I'll still get my full data set S1. I'll still get all of this. Because this one was just returning me the values that are in S1 that are not in S2. That is all it was doing. Then difference update, what difference update will do is that difference update will look for the elements that are absent in that are in S1, that are common in S1 and in S2, and then it will delete those common elements from S1. That is one difference update to do, and that's why when I run this, I don't even need to assign it to S3 again because I was just trying to understand the function of that. So if I run this and I ask what is S2, you see S2 remains the same. S2 remains the same, but if I ask what is S1, S1 has changed. I hope that is clear, so you do not confuse the two.
Yeah, it's okay now. Thank you, Prof.
Yeah, so we don't have to confuse those two concepts. Now let's look at something. Discard. Is discard the same as throw away?
Yes, it is.
Okay, so let's see. So am I discarding a specific element? So let me just do S1 dot discard. Maybe I discard what, 5? Is there 5 in S1? Okay, now the new S1 that I have has 5. And so if I return S1, S1 does not have 5. So we have thrown away 5. And that's what this card does. Okay, let's continue. This card just throws away, right? We have intersection so let's rerun this because we've changed a lot of things. So let's do intersection and so intersection is just going to be the same thing, right? So we say S1 dot intersection S2 and it returns the numbers that are common. We already know that. intersection update. So it's going to do the same thing like difference update did. So if I do intersection update, it's going to delete something from my S1.
It has been something that
Updates.
has probably been happening over and over. All right. So he had nursed that jealousy and envy in his heart to the point where this particular incident was the last straw.
So if we run this and then we return S1.
Enough to get you to commit murder. So the very first murder in the history of mankind.
So when we run this now, we see that S1, the values of S1 have changed. All the values that were common between, it retains all the values that are common between S1. Madam Vanderlyn, please, can you mute yourself? Because there's some noise from your background, please. So that is, so let's see. Let's see some other functions again. Okay, we've looked at this one. Intersection will return a set of the values that are common. Is disjoint. Okay, now what's a disjoint set? Can somebody help me tell me what a disjoint set is? What is a
So two sets
disjoint
are
set?
disjoint if they have no elements in common.
Oh, what is a disjoint set? Well, so why is this guy not a pair of sets which does not have any common elements are okay? That was a perfect answer, right? So, and looking at the way the function looks like, so it's gonna give us a yes or no, right? So let's rerun this, right? Just so we just know that we've not changed. So if I ask S1 dot let me copy that thing. I don't want to start typing and then I want to type something that I have in my own brain. S1 dot is disjoint S2. So now, so we expected a false, don't we? We expected a false, right? Based on the definition, we expected the false. All of you quiet.
Yes, it's supposed to be false because it's not a disjoint
Because we
set.
have two, we have four, we have 6 and 6, right?
Yeah.
Okay, good. The next thing we want to see is subset. That means all the elements of one set are in the other one. So if I ask, is S1 a subset of S2? Oh, subset. Did I spell it wrongly? Oh, I was supposed to say is subset, right? I was just typing it as if I'm typing my English. Let me change this to is subset of S2. I get false. Why is it false? Because not all the elements in S1 are in S2. That's why it's not a subset. So we have it's a
Well, I
superset.
was
It's the
still
opposite of
thinking that,
subset.
okay, it's understood now.
Superset will be the opposite of subset. It's asking whether this other set contains all the other elements of the other one, which you see before. Pop, the same thing. Remove, the same thing. Symmetric difference. I don't know about this one. So let me check the symmetric difference. S1 dot symmetric difference S2. I don't know about this one. So it gives us, it returns, okay. So what it happens is that it returns the elements that are in S1 and not in S2, and those that are in S2 are not in S1. So it just brings out the difference in both sets and put them together, right? 1, 2, 3 is in S1 and it's not in S2. 8, 10 is in S2 and not in S1. So that's the symmetric difference. And if you do the update, right, I think it should update S1 to the symmetric difference. So S1 should then become the symmetric difference if I'm not. Symmetric difference, I think it has an update. So if I do this and I run it and I return S1, I think S1 should be the symmetric difference, of course, as I expected. So we're in line. Tora. Union of two sets. So our S1 now is this, so please don't make a mistake.
Please, I did not understand
Yes,
symmetry.
Mr. Look at 1, 2. Let me run this back because if I do not show you this set, you will not understand it. So let me rerun this down here. See, set 1 has 1, 2, 3, 4, 5, 6. Set 2 has 2, 4, 6, 8, 10. If you look at set 2 does not have 1, 2, it does not have 1 and 3. 1, 3, and 5, sorry. And set 1 does not have 8 and 10. And so what symmetric difference does is it looks for those values in S1 that are not in S2, and then also look for the values in S2 that are not in S1 and bring them together. And that is why we have this. And a symmetric difference update will just update S1, the first value here, to the symmetric difference. Is that clear?
So are we saying
You
that
just carefully look at these two sets and then look at this output. You understand what I'm
Please, what
saying?
of is disjoint and is subset? I was kicked out by network, please.
Is disjoint. A disjoint set is a set that do not have any element in common. Any elements in common. If a set does not have any elements in common, it's a disjoint set. So we cannot say A and S1 and S2 are disjoint because 2 is here, 2 is here, 4 is here, 4 is here, 6 is here. So it's not a disjoint set. So when we run that, we are supposed to get a false. That's why we got a false, of course. It's a subset. Subset means if I ask, is S1 a subset of S2? It means I'm evaluating if all the elements of S1 are found in S2, but which is false. That's why I got a false when I asked for subset. Yes, somebody was still asking a question before we talked about subset.
Yeah, does it mean asymmetric difference now will be the same as normal difference?
I don't know. Do we have a function called asymmetric difference? No, I don't have such a function here.
All right.
So I will not know. So we just have difference and symmetric difference. So we don't have another function called asymmetric difference, right? These things are just there to help you. There will be time that you get stuck somewhere and you need this logic to solve a problem. Trust me. Take it from me who has been in this field. There'll be a day you get stuck somewhere like that. You need a logic to return a certain value. And if you've forgotten all these things, you find yourself troubling, going through, but you remember one of these things and it will just come in like a savior and save your life from headache. So union will just combine both sides. So if I do S1 dot union, then I pass S2. It just brings both sets together as expected. Without repetition, of course, we know sets are unique. So you wouldn't expect the values to replicate. So update, I think I can update S1 with 7. S1 dot update with 7, right? And if I, it's supposed to take an iterable. Int object is not iterable. Wait. Tab. Object update takes an iterable update set with the union of itself and others. Built-in function or method. Okay. But is this an iterable? Let me see something here. I was thinking it would take a single value, so let me use S2 and see something. Oh, serious one. We updated S1 with this. Okay. I think, okay. So it's like extending the set, right? So if you want to add an individual element, you actually have to explicitly use add, not update. But if you want to extend a set with another set or another iterable, it says it's an iterable, so I can also pass a list, of course. Because if it's asking me for an iterable, I think I can have a list and then I have 10, 20, maybe 30. And then if I run this s1.update and then I pass that iterable there, which is R, should work. It says it should, of course it worked. But it said it was expecting an iterable, yeah. Great. That brings us to the end of the common functions in sets. Any questions? Any questions? If you don't have a question, that means I can happily move ahead.
Pro Boris, please, I have a little worry.
Okay, sure. Let's address that.
Yeah, please, I just want to understand when you say you are updating a set, let's say with the example that you took previously, you were updating S1 with 7. Please,
It did
can
not
you
work because 7 is not an iterable. It says the function update explicitly takes an iterable. So you cannot choose to add your own. It must be an iterable. An iterable, like I explained last time, is a kind of data type that you can loop over.
Okay.
That is why when I said update and I used 7, it did not work because I cannot loop over an integer. You understand?
I get
And
you.
if in a case where I want to add 7, if I want to add 7 to my S1, I'll explicitly use the add function, not update. There is an add function, right? I'll explicitly use this one.
Okay.
But if I want to update it with something longer, a list or a tuple or another set or something, I can use update. But I cannot update with a single number. It will not work because by default or by convention, the update function accepts an iterable. Is that clear?
It's not a prof. Thank you.
Awesome. Okay, the last thing we talk about frozen sets, and then we go to something else. So we can now, we said sets themselves were immutable, but frozen sets are not mutable, are immutable. So you cannot mutate frozen sets. Okay, let's see. So if we say S1, right? S1, and we can go ahead and say S1, dot add, maybe let's say add 40. We can add 40 to S1, of course. That because S1 is mutable, it's going to work. But then if I say S is equals to S1 dot frozen, right? I hope it's frozen. Do I froze? Is it frozen? Then you pass the object inside, or you do, oh yeah, it's frozen. The word is frozen set. So I have to do this. S equals to frozen set, that's a function. And then I pass S1. And if I return S gives me this. And let me try to add an element to S. So I will say S dot add. And then I want to add maybe 50 to it. But it's a frozen set, of course. It says frozen object has no attribute add because frozen objects are not mutable. So because sets are mutable, if you want to make them immutable, you have to freeze them. That way you cannot change them. I hope that is clear.
It's clear, prof.
Okay. That takes us to the end of sets. Is there any other question? Any additions, subtractions, inputs? Okay, awesome. Let's look at dictionaries. So in the same line now, we've talked about sets. There's another data type called a dictionary. Just from the word dictionary, Abby, most of us have used dictionaries now. Mrs. Jamin, tell me something that you use the dictionary for.
I most of the times use the dictionary when maybe I'm writing a speech or I'm going through a document that has with some vocabulary that I need to relate to the context that
So
I'm working
what
with.
is the function of the dictionary specifically? Why would you open that dictionary? So get the meaning of a word, if I'm not mistaken.
To look up spellings.
Yes. Or you can look up spellings or look up the meaning of a word, right? Or something like that. And most of the time, let's say we look for a word like mutable. You are going to, in the dictionary, is going to be like this. They are going to put it like this, and then they put column, and then they put the meaning. Says reliable to change, right? To change, right?
Yeah.
And so in programming, we call this the key. Sorry, not everything, just this one. And we call this the value. That's the same concept that this other dictionary is all about. So let's see how it works. So it is an ordered collection of multiple data elements which are stored in key value pairs. I still repeat, I still use the word unordered, right? So I hope you already understood what I meant by unordered. And it says multiple elements stored in key value pairs. So let's see how to create dictionaries. So how do I create a dictionary? Okay, let me create the dictionary, okay? So I said the elements are stored in the form of key value pairs. I do not want, if I run this, okay, gotcha. So now, let me see, how do I create a dictionary? So I'm gonna call my dictionary D. Well, and it's gonna be equal to, so to create a dictionary, I will explicitly use curly brackets, or now, somebody will now ask me, what is the difference between a dictionary and a set? Please freeze that question. Don't bring it now. We're gonna answer it as we go ahead. But then in a dictionary, look at the way I'm going to store my values in a dictionary. Let me see, I'll see name, which is going to be my key, and the value is what? Boris, which is going to be the value. And then comma, this is going to be one element. I'm going to put a comma, I want to put the second element, and it's going to be, this one now is going to be H, and it's going to be what? My H is going to now be, let me see, I can say 45. And then height, I can see height, sorry, you can see height, and my height is going to be 1.7 meters. What happened to you now, bro? How did you get outside there? 1.7 meters. And then let's see, we can even talk about the weight, right? It should be string. So we can talk about the weight, and it's going to be, say, 70 kg. And then we can, and then, sorry, 70, not 10, but, and then we can talk about something like the sex, and lowercase. Sex is going to be male, right? Going to be male. Okay, great. So now I want you to look at the way I've stored these values in, this is a dictionary. I've created a dictionary here. Maybe this dictionary, the name is trainer, for example, who is training you. Okay, this is going to be, so what is his name? Name is the key, and the value is Boris. H is, and then, you know, you people use this when you see you now. The reason why we have this, right? Let me tell you why we get dictionaries. You know, forget, you know, when we have lists, right? You have to search elements in lists using their index numbers, right? You search elements using their index numbers. And so you have dictionaries coming in such a way that if you don't have to use indices, you have to use names. And that's what happens with your phone. The way you store people's number in your phone, you use their name so that when you want to search for them, you just search for that name. That name serves as a key, as a value, sorry. Wait, key, yeah. And then the value is the person's phone number, yeah. So you have the key value pair kind of appearance. And if I print trainer, and I print the type of trainer, I would get that trainer. And if I return all of these, I get, this is my trainer, and trainer is a dictionary. So I'm confident that I've created a dictionary. Yeah, I'm confident that I've created a dictionary. Now, we've created a dictionary. That's it. So can I create an empty dictionary? Yes, of course I can create an empty dictionary. So if I want to create an empty dictionary, let me call it Z. It's just going to be this. Oh yeah, now you're asking me. If I print, let me just copy this because I don't want to type a lot. Let me print D, and I print the type of Z, right? It's going to say Z is a dictionary, of course. But you see here, that is why I told you back in sets that when you are creating a set, you don't create a set and just put curly brackets like that. If you want to create an empty set, you must have to explicitly pass the word set in front here, because if you don't, what you're creating will be a dictionary. That's when you're creating an empty set. So you have to explicitly say this is a set. Otherwise, you end up with a dictionary. I hope that's clear. That is it for a dictionary, for the creation of a dictionary. Properties of a dictionary, we say key value pair. So keys are unique. What does it mean by keys are unique? You can't have the same key. You can't have name and name again. For example, I already have my dictionary called trainer. I cannot go ahead and then I do H again, right? I cannot do, how do I write this other H? It's like this. I cannot do H and maybe say 40, for example. And if I come back and tell trainer, you see, it does not, it just automatically replaces, it doesn't return, you see, it doesn't return H twice. I don't know if you've noticed. There's H here, 45, and there's H here, but it doesn't return that. So it automatically returns this one and ignores this one. So it can't return the same value twice. So what I'm saying is that the keys are unique. These are the keys. They're unique. They're unique, meaning that they cannot be duplicated. You cannot have duplicate keys. Okay. Keys should be immutable. Keys should be immutable. What does it mean? I can't have my trainer and I come here and I see, and I can't do this, right? I can't have a list here. So I'm gonna have comma. Maybe say if I have name, maybe say number, and address maybe. And I cannot have these. And then, okay, now you see, this is going to be serve as my key, right? It's mutable because this not mutable key, but doesn't mean you cannot have a mutable value. You can have a mutable value. Please take note, I'm talking about the key. The key cannot be duplicate. You can have duplicate values, but not keys. Because my height can be the same as my weight. My age can be the same as my weight. But that doesn't mean that my name can also appear. Name will be name as a key multiple times. So I hope that illustration is clear. We cannot have mutable objects as our key values. The next thing is that values can be mutable and immutable. So our values can be anything, right? Our values can be anything. For example, if we still go back and use our trainer dictionary as an example, only for name, I can have 10 people bearing different names, right? So for name alone, see, this is name. So what I'm going to do is I'm going to wrap this value as a list. Oh, sorry, as a list. I want a list. So I'm going to kill this, right? So Boris, for example, I have 3 names. So you can see all my 3 names. Oh, sorry. So my 3 names are Boris, John, right? Then something like the other name can be something like this. Then I can close. I have to close it here. So now I have 3 names here. That's the value of course. Okay, so if I return trainer, right? You see I got that, right? That was returned. It's possible that my values can both be mutable and immutable. So it's up to you. Okay. Indexing is not allowed. What I do when you're using dictionaries, you're not talking about indexes again, because if I say trainer, what I'm talking about is if I say trainer position 0 and I run this, it returns an error. It returns an error. So now you're going to be asking me now, Prof, if I want to fetch the H, what am I supposed to do, right? So if you want to fetch the H, you have to explicitly say trainer, and then you say, I'm looking for and once you run that, it will tell you the H is 40. If you want to fetch the name, you're going to say trainer, right? And then you say of the trainer, and this returns the names, right? So you can like this. So what are things? Yeah, you can traverse. So indexing is not allowed. We just illustrated that. Yes, you can traverse. So if I say for print I, for example, I get name, age, height, weight, sex. Now you notice that it only returns the keys, not the values. But we're going to see. As we go ahead now, you ask me, what if you want to return the values? We are going to see as we go ahead. Okay. How to fetch an element in the dictionary? I've shown you nested dictionaries. Yes. We said, well, the only thing we said cannot take another thing is the keys cannot be mutable, right? So we can have a nested dictionary, of course. So let's use our trainer dictionary. What aspect of trainer can be mutable again? So let's say this was our trainer, right? Of course, this was our trainer. We want to add something for our trainer, right? And we want to add the address of our trainer. So, we can do address like this, right? You know that we can do address. And the address is supposed to be a double D, I guess so. And so if we do address like this, we can do this. Now within my address, right? I can have another dictionary, right? And within this dictionary, for example, I can have my city, and then I can pass my city value, which is Bamenda. I can have maybe a region value. can have a region value, region, and then I'm gonna have a value of a region which is maybe Northwest. So this is another dictionary, right? That's my region. And so if I run this, I get that, right? So you can get that within a dictionary, right? And if you want to see, I want to know the address of my trainer, right? And then you're going to do this. What is the trainer? And then you're looking for what my address, right? And then you run this, it's going to tell you city is Bamenda and region is Northwest. Okay, great. Great. So we've sent a dictionary within a dictionary. So that is nested dictionaries, of course. Common functions. Everything still stays the same. Oh, let's look at some, for example. Would some work? I don't think so. So I wasn't supposed to have some here. Let me take this one out, okay? It's not supposed to work. So, some can work in another way, but not direct like that. That's why I'm taking it out, but we'll see. Before we go ahead, any questions before I go to the specific functions? Is there anyone who is confused? Diffuse,
Prof,
refuse.
can you hear me?
Yes, I can hear you.
Please, can you quickly
Yes,
run over
please.
this dictionary again? I mean, network, I mean, I've been battling network issues.
You've been battling with network issues?
Yes, it
Very
takes me
few.
off.
Very few things. We've just been focusing on the properties of a dictionary, right? And we said it's very simple. The keys are unique, right? Keys are unique, meaning I can't have the same key multiple times. And I illustrated that here. When I have H and I added H again, right? Was this here? I have H here and I have H here. Once I print that, you see I didn't have H occurring twice, right? You see, this is H45, H40, only one comes out. So you cannot have the same key twice. This is a key, this is a key. It cannot be twice, right? This key and this key. So keys must be unique. Keys should be immutable. Keys should be immutable. So your keys should not be changeable. And so I illustrated that by creating a mutable key. I created a mutable key somewhere, right? Oh, did somebody change something? Oh yeah, I created a mutable key here, you see? I created a mutable key here. And it told me that on hashable type of list because my key was mutable. And so it wouldn't accept a mutable key. Values can be mutable and immutable. Yes, you can have any kind of values, right? And I illustrated that by saying that I can have a mutable value and all these other ones are immutable. It doesn't matter. Once I print this, I get my result, right? I went ahead to say that dictionary, that a dictionary is mutable. Yes, you can add an element to a dictionary. I know I didn't show this. And then they say indexing is not allowed. Indexing is not allowed. Of course, I proved that indexing is not allowed here. Where is that? Where is that? Okay, yeah, indexing is not allowed. So if I do trainer position of 0, it returns an error. But lists are mutable. Sorry, dictionaries are mutable. I can have trainer. And in the trainer, I can give a key, right? My key this time around, say like I can say like football, right? Football as a key. Maybe I'm asking if I play football. So I'm just asking, let me just call it football, okay? And I can assign the value to true, right? And if I return trainer, okay, I have true as football. So I've added a value, so it's mutable. This is proof that it's mutable. I've changed it. I've added a value, right? So that is it. Is it okay now, Mr. Tony?
Yes, it is. What about fetching something from a dictionary?
Fetching something from a dictionary, just pass the key. If I ask what is the name of my trainer, I get it. If I ask what is the age of my trainer, I get it. If I ask what is the address of my trainer, I get it. But I cannot use indices. I cannot do trainer position 0, like we already know. Is that clear?
Okay. Yeah. Thank you very
So
much. Thank you.
I can use the keys to fetch. Okay, great. Let's round up. Now let's look at some of the specific functions in dictionaries. Yeah. And the traversal, of course, you can print. You can look. So let's do the arrow. We're printing the directory of dictionary. As you can see, the short form of a dictionary is DICT. So clear and copy, we already know that from keys. There is something called get. From keys, I've forgotten this function, but let's handle this one. So I'll get back to this one. If I say trainer dot get, if I say dot get what? Sorry, dot get each, right? It gives me 40, right? But let me tell you about, let me show you something. Trainer dot get, I want to show you something. Dot get something that is not available. Let me say handball, for example. I do not have handball there. If I say trainer.get handball, it doesn't return an error message. It doesn't also return something. But if I had done trainer, and then I said handball, which is what we already know before, how to fetch, right? It returns an error message. So the difference is that get will not return an error message, but by default, if I do not have a value, I can also print, because if I print this before, let me see if let me just comment this out, okay, before I go. I can, oh, sorry. I can print this, okay? I can print this. And if I print that, you see it returns none, right? But in a case where I don't want that, right, I can do this using the get function. I can do this. Not found. You see, it now prints not found. It's looking for handball. Handball was not available, so it returns not found. Right. So that's how you can customize the get function to get some cool stuffs. Items. Okay, so let's do trainer dot items, and then I'm going to print this, okay? I'll explicitly print this, because if I don't print this, it will give me a funny output. Items is a function. So I have to explicitly run it as a function. You see, it returns my dictionary as a list. Did you notice that? It returns my dictionary as a list. And now look, let me show you for something. Let me say, for I in trainer.items, for I in trainer.items, I want to print I, right? Look at what we get. You see, it returns those things as a tuple. key value pairs. But you remember when we looked through it initially, see when we looked through here, we only got the keys. So if you want to return the whole data within your loop, you have to run with the item function. And from here, I can explicitly pick only the values, right? Because I can do this and I say I want only position number 1. And it will return only the values, right? Oh, shit. Says non-type print. Sorry. I was even writing nonsense. You see, it returns only the values, right? So that's how the items function work. You can use it. It's very handy. So now let's look at another one. Pop, the same thing. Pop item. Pop item. The only difference between pop and pop item is oh, let me see. What's the difference between pop and pop item? Let me just be sure. Pop, we already know pop. So what is the difference? Is the difference between pop and pop item in about the use of pop and pop item to remove elements from a dictionary. They are actually different. Pop can remove any item from a dictionary as long as you specify the key. On the other hand, pop item can only remove and return the value of the last element in the dictionary. So this is the definition. This guy, as long as you pass the key, this guy will remove anything. This guy will remove anything, but this guy will only remove the last element. So let's see that. So if I do trainer dot pop, I want to just go for pop item because we already know how pop functions. So I have to run this and it returns football, right? But let me see. I want to do trainer dot pop. And then I'm doing one football. I want to see, I want it to pop H, for example, which is not the last element. List. And I'm going to run it and it gives me an error message, right? Because pop item only removes the last element, I hope you understand that. But if I were to change this to pop, pop will remove anything, but for it will remove anything. So it takes it out. And so if I return my trainer now, see, we don't have H there, we don't have the other functions there. I hope pop and pop item are all clear. So set default, I'm here to look at that one. Update is the same thing. You want to, it takes an iterable values. There's this one called keys, okay? Now I like this one because you're going to use it a whole lot. So let me look at trainer dot keys. Keys is a very good function. It returns keys. So if I run this, it returns your keys. And if I take trainer, right, and then I return the values, which is the last function down there, values, it returns all my values, right? So you can also look through this or you can look through this. It's up to you. You can do for I in trainer.values and you return values or something. For example, if they tell you to pick Bamenda, if they tell you to print Bamenda, right? So what do I say? Can I do trainer dot values, trainer dot values, and then I return. Now trainer dot values, I have to take the last element because by default this is going to give me a list, right? And then in the last element, I'm looking for city, right? So if I run this, oh shit, dictionary object is not subscriptable, but this trainer is not a dictionary, right? Trainer returns a list by default. Trainer values, it returns a list, right? This is, oh, it says dictionary values, but then I don't want that. But let me point this. I'm just gonna copy this. Let me cut this first. And then I point this to V, for example, and then I run this, just I wanna check out something, okay? And then I return V, and V is the dictionary value. I wanna get a type of V. I wanna get a type of V because C is a dictionary, and I'm just, oh, it's a dictionary value. Oh shit. And so if I actually wanted that thing to work, it would have been this. Or should have been this. Oh shit, I actually had to remove my thing. And then if I do this, I have to do CD, for example. CD, but then I have to explicitly say I want this as a list, okay? I want this as a list. And then if I run this now, it should still doesn't dictionary value object is not subscriptable or then but in here. So I'm gonna clear this up. Maybe I just delete this cell, for example, but I have to cut this so that I don't have to type this thing the second time. So what I can do is I can do list of V. Yeah, V. Yeah, it returns that. I can do this. List of V, it returns that. So maybe I can assign this to val, for example. Val, for example, and it returns this. And if I return val, it should return this. And if I now do val, and then I paste what I had, position -1, and looking for CD, it should return that in there. Of course, that's what I was looking for. Great, 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 great. That is it for values and items. So two things we did not look at, ID from keys. Let me look at what this one does. I know what it does. From keys in Python. The from keys method returns dictionary with the specified key and the specified value. Syntax dictionary from keys, key value. No, so maybe let me see use case. Let me see use case. Keys in the dictionary, alphabets, number. So output dictionary equals to dictionary dot from keys, alphabet, number. Okay. So we can use the from keys to assign to explicitly assign values to. So what, looking at this example, if you want to explain this example we see here, what we're saying is that we can have alpha as our keys, as our values, and we can just say, maybe this can just even be a list, and we have, and we can have maybe A, for example, comma, B, comma, C, for example, just for example, and then I come down and I say num, for example, I can just say 1. And then if I run this, oh, so something didn't work somewhere. Oh yeah, this expression this. If I run this, I can see Dick, for example, should be equals to from keys, right? And then I pass this, I have alpha, 1, number. And so if I return the IC, did I spell from keys wrong? Name from keys is not defined. Did I spell it wrongly? keys, from keys. What did I write there? What did I write there? From keys. This is correct, right? Something's wrong here. Name from keys is not defined. Let me see the use case again. Oh yeah, this object was supposed to be in a dictionary, sorry. Not a list. This was supposed to be a dictionary. Where is that? Oh no, here. This was supposed to be a dictionary, not a so it's supposed to be this. And then now we can run this now. See the network? Wonderful. Crazy. What if this was it? What if this was? So now let me see something. Because if I'm using the dictionary function, then I must not tie this guy to a key, right? To a list. This guy can be a list. This guy can be a list, right? And then I can now use you because I'm explicitly saying I want a dictionary here. So if I run this, I should get, I see if I run this, I should get it. Yeah, awesome. So works, great. So from keys, you can just use it to easily attach or assign values to your keys, you know, just like we've done, right? You see each key has taken a value of 1, 1, 1, 1. You can put anything there. I don't know, the use case where you're gonna find yourself having to use this. What I'm doing here is that I'm telling Python that you are using this from key because it kept telling me that it was not defined. So I'm telling it that, okay, you are using this from key from dictionaries. And then I pass my parameters and it just works like magic. And there was a last function I didn't take a look at it, which was set default. I know it has to do something with the keys, but these are some functions that I've never used before. So let me see what it does. So I can run this set default dictionary method. The set default method returns the value of the item with the specified key if the key does not exist. Okay. Oh yeah, that makes some sense. So if I come and say trainer dot, I think set default is still okay. If I say trainer dot set default, if I see age, for example, right? If I run this, can I print this? Print this because it's not giving me any output. Let me see. If I run this, it gives me none. Oh, did we remove H? Did we remove H from that? Oh yeah, we removed H. Oh shit. So if oh shit, I'm looking for you. So if I put past something that is still existing, like name, for example, name. So we can run this and it gives us, it returns a name. But then you see, if I, just like we did for something when I was talking about get in set, if I set default and it doesn't exist, I can say does not exist. Does not exist, right? Does not exist. So, and I run this and I get, this doesn't print, does not exist. It's supposed to print doesn't exist. So, okay. Let me see something about trainer. Let me see something about trainer dot set default. Set default. I'm looking for something. And default. And if I pass this and I do shift tab, let's see what we get. So it says a key, default values to none. So if I say default, if I change default, right? If I say H, for example, H, and I said, and I pass default to maybe, can I see 20, for example? Do we get a value? And then I run this, it gives me a result. Dictionary says default takes no argument, keyword arguments. Why is it rejecting my way? Because I want to set default to, what if I just see? It's setting it to none, right? So what if I change that? Let me see something. For this here, I use set default. Can I see a use case? I just want to see how they play with that. Brandford, blah, 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 set default model, uncle. So when you print this, what do you get? Play it yourself. So if I run this, what do I get? I get Mustang. What am I getting? Why am I getting Mustang? So if I run this, I'm running this. Why are you pointing me somewhere else? I'm running this. A mistake this. Come here, run it. Gotta set default. I have to first of all do, can I do here now? Not set default model. So if I run this and I return X, this is Bronco, right? But if I return trainer, this is Bronco. Okay, gotcha. So mine wasn't working because I didn't assign it to a variable. You crazy guy. So now set default is, what you're saying with set default is you're looking for a key, and if the key does not exist, it should create the key and then you give it a value. That's what we're saying. So for example, if I use this, right? If I override this and then I use H, for example, no, not H. We already have a key called name, right? If I run this, right? And then I ask for X returns Boris. You understand? So it doesn't set the value to Bronco automatically because this value, this key was already existing, so it doesn't change it. But look at something. If I want to ask for something like this, if I do this and I say H, and I know we don't have H in our trainer data set, and if I return this and I ask what is X, it's going to tell you that, oh shit, did I run this one? Is it the writing is? Oh, we already have H. Wait, let me see. I'm sure we added H already. No, there's no H. Oh, there's H that was set to none. Oh shit. So it was set to none. So yeah. So let's do for something like what other variable can I use? Okay, no, I know we don't have something like handball, right? Let's see handball or football, for example. I know we don't have football. And I can set football to value to good, for example. And now if I run this and I ask what is S, it says good. And if I return trainer, you see I'll have football there. It says the value so good. But if the key was already existing, it would have not put this value. So that's what default. That's what I was trying to prove. And just because I wasn't assigning this to a variable, the guy kept giving me an error message. Okay. Any questions so far? Do we have any questions? Okay, awesome. In the absence of any question, then we call it quit for today. And then we see you all in the next class. Bye-bye.